Hey everyone. So today I just want to go over lesson 2, chapter 9, over geometric figures. Let me get my slideshow started. Okay. My name is Heather McPherson, and I hope that I can give you a better understanding on some of these geometric figures. First, we have two parallel lines and then two lines that connect that form a triangle. We have 12 different angles that we need to figure out. So what I do personally is I look at the ones that we already have. And as you can see, 63 degrees right here and 61 degrees right here. So I know that 2 is vertical to the 63 degrees. So angle 2 is going to be 63 degrees. And then again, over on this one right here where it's 61 degrees, 9 is vertical, so we know that angle 9 is going to be 61 degrees. And so now we can look at the inside. So we already have 2 out of 3 of the angles for the interior of the triangle, and we know that the interior angles are going to equal 180 degrees. So when you take 180, subtract 63 and 61, you're going to end up with 56. So angle 7 is 56 degrees. Angle 1 is corresponding with angle 7, so that one's also going to be, angle 12 is vertical to angle 7, so it's going to be 56 degrees. But again, like I was saying, angle 1 is going to be corresponding, so it's also going to be 56 degrees. And since 5 is vertical to 1, that is also going to be 56 degrees. Now we're going to look at angle 3. And the reason why angle 3 is 61 degrees is because angle 1, 2, and 3 have to add up to 180 degrees. So the same that we did in the interior of the triangle, we subtracted 180. We took 180 and subtracted 63 and 56 to get 61. Angle 4 is vertical to angle 3, so it as well is going to be 61 degrees. And we are left with angles 6, 8, 10, and 11. And the way you figure out angles 8 is that you know that 7 and 8 are supplementary, so their total has to equal 180 degrees. So angle 8 is going to be 124 because 180 minus 56 is 124, which then makes angle 11 also 124 degrees because it is vertical to angle 8. Again, with angle 6, you're going to take 180, subtract 61, and you get 119. So 119 degrees for angle 6 will also be 119 degrees for angle 10. So we have angles that correspond, angles that are supplementary, and angles that are vertical. Just remember when you're working with supplementary angles that they're going to equal up to 180 degrees. All right, now we have a triangle with the points A, P, C, Q, R, and B. We are given angle B, which is 26 degrees, and we're given angle C, which is 74. Now they want us to find the other 8 angles. Well, we know that angle B is congruent to angle 4, and congruent just means equal to. So angle 4 is going to equal 26 degrees. Along with angle C is congruent to angle 6. So angle 6 is going to be 74 degrees. And then you have angle 1, which is going to be congruent to angles 3, 8, and 5. So as you can see, they're all pretty much the same angle. So they are going to be equal to each other. And then you have angle 1 that is supplementary to angles 2 and 7. And remember when I said supplementary means you're just going to add them together, they equal 180. So if angle 4 is 26 and angle 6 is 74, you would add those two up and then subtract 180 from it, and you get 80. So angle 5 is going to be 80. And since we know that angle 5 is congruent to 1, 3, and 8, all 1, 3, and 8 are also going to be 80 degrees. And again, I said angle 1 is supplementary to 2 and 7. So what you would do is you already know that it has to equal 180 degrees since angle 1 is 80. Then angles 2 and 7 are both going to be 100 degrees. Now we want to work on concave polygons. And how do we figure out the sums of the interior angles? So what you're going to do first is you're going to pull up your equation, n minus 2 times 180 degrees. N is going to represent the number of sides your polygon has. So in this case, our polygon has 8 sides. So we're going to do 8 minus 2 times 180 degrees. All right, and that's going to give you 6 times 180, which is then 1080 degrees. So that's what the interior angles have to equal up to, is 1080 degrees. All right, so again, now where do we go after we figure out what the sum is altogether? You're going to take all these angles, 3y, 7y, and 12y, all of the interior angles, and you're going to add them together. And again, they're going to equal 1080 degrees. So then you get 54y equals 1080 degrees. 1080 divided by 54 makes it where y equals 20. Now that we know what y is, we know that we can put 20 into the place of the y on all of these angles. So you have 3y equals 3 times 20, so it's going to equal 60 degrees. So everywhere that you see a 3y, you're going to know that that's a 60-degree angle. Next, you do the 7y, so it's 7 times 20 is going to be 140 degrees. So on the 3 top angles, you know that they're 140 degrees. And last, you're going to do the 12y, which equals 12 times 20, so 240 degrees. If you wanted to check it, you could go ahead and add 60 degrees 3 different times, because you have 3 angles that are 60 degrees. You have 3 angles that are 7y, so that would be 140 degrees, and 2 that are 12y, which is 240, and you would come up with 1080 degrees. Alrighty, now we have an octagon, and what we're trying to figure out are the interior angles, the center angle, and the exterior angle. So we're going to start off with the interior angles. And again, your equation is going to be n minus 2 times 180 divided by n. N is still the variable that represents the number of sides that we have in our shape, which this being an octagon, again, we have 8 sides. So you'd have 8 minus 2 times 180 degrees, and then divide that by 8. So you have 6 times 180 degrees divided by 8, and you're going to have 1080 degrees divided by 8 to come up with 135 degrees. So all of our interior angles are going to be 135 degrees. Sorry. Next, we want to work on the exterior angles. That equation is going to be 360 degrees divided by n, again, which is the number of sides on your shape, on your polygon. So 360 divided by 8 is going to be 45 degrees. So any of our exterior angles are going to be 45 degrees. And what's crazy is that the center angle, it's the same equation. So you're going to do 360 over n. 360 over 8 is going to be 45 degrees. So your exterior and your center angles are both 45 degrees. Ooh, now we're going to work with a cube. And this cube we have angles D, H, E, and G that you can see. Now the first one that I'm going to pull up, we're looking for a tetrahedron, which is a triangular pyramid. And so when you draw out your cube, then you're going to go ahead and draw out your sides like you had before. And then you're going to draw out a tetrahedron. It has 4 sides that you can see, and it looks like a triangular pyramid. This next one that we're looking at, we draw out the same cube, but the shape that we're looking for doesn't have the planes showing. We want the faces of the tetrahedron that aren't the faces of the cube itself. And that's what this other figure is over here, all drawn out. And now, what are we looking at? So this first one is a tetrahedron. And as you can see, as this rotates, you have 4 different angles, 4 different sides, 4 different planes. Is that because the definition of a tetrahedron is a 4-plane object, 4-plane faces. So now that we have the tetrahedron, the next one that we want to look at is the octahedron. Now this is a, just instead of the 4 that you see with the tetrahedron, an octahedron has 8 faces. So every time it spins, or where you're looking, you're going to see 8 plane faces. As you can tell, it's got 4 on the top and then 4 on the bottom, 4 on the side. So you'll always see about 8 of the plane faces. The last one we're going to look at is an isohedron. Sorry, I'm not able to really say that. And this one has 20 plane faces. It looks a little bit easier with the 3D model. And for me, I just learned the most common one that we're used to seeing is actually a soccer ball. It works with a hexagon instead of triangles. So I hope I was able to give y'all just a tad more information on geometric figures, and I hope you'll have a good day. Thank you.